Hi, this is Damien from Platform 9. Let's talk about installing Private Cloud Director Community Edition on VMware. Why VMware? Well, the reality is that companies who are exploring VMware alternatives will want to install it on VMware because that's the virtualization platform they have today. In this video, I'll point out a few gotchas within vCenter and the Ubuntu installation, walk through a complete Community Edition install, plus some post-install configuration. So let's get started. I'm going to create two virtual machines, one for Community Edition and the other to act as a hypervisor host. Since I'm using Ubuntu 24 for the operating system, I'll choose Linux and Ubuntu, give it 8 CPUs and 32 gigs of RAM, and 160 gig thin provision disk. For simplicity's sake, I'll give each VM only one Ethernet interface. I'll mount the Ubuntu Live Server ISO to the VM and then finish the wizard. Next, I'll create the hypervisor VM using the same Ubuntu distribution, giving it 8 CPUs, but this time I'll enable hardware virtualization to allow it to run nested VMs. I'll give it 16 gigs of RAM because I don't need much for this demo, also do 160 gig thin provision disk, and attach the ISO. Finally, I need to edit the vSwitch the hypervisor VM is on to allow promiscuous mode, MAC address changes, and forged transmits. This will allow nested VMs to get out to the physical network. The install process is fairly straightforward. I need to give the CE host a static IP since I don't have DHCP in this lab, and then I'll move through to the OS storage configuration. By default, the Ubuntu install wants to use logical volumes, but it won't allocate all of the available physical space to the logical volume. I have to manually edit the storage allocation, or otherwise it may not end up with enough storage to meet Community Edition's prerequisites. After this, I'll create a username and a password, grab my public SSH key from GitHub, and then complete the install. After it reboots, I'll log in and update the operating system to get the latest patches. After the operating system updates are done, I'm going to log back into the VM and then switch over to the root user to begin the Community Edition install. This will take about 45 minutes, but with the magic of video editing, it takes about 30 seconds. When the install is done, the installer will print out the installation status along with the default administrator account and a random password. Since I'm still using the VMware console at this point, I'll get these credentials when I need them in a bit. I'll switch over to using SSH via a terminal because that makes it easier to copy and paste commands. This is the content of my local host file, which allows me to resolve the CE IP address to its fully qualified domain name. I'll switch over to the hypervisor host and make sure it can resolve the CE host. If I don't do this, I won't be able to onboard the hypervisor in a bit. This is also a good time to see how Ubuntu has named the Ethernet interface because we'll need that for the Community Edition cluster blueprint. I've also logged into the CEVM over SSH so I can grab the administrator credentials. Now it's time to log into Community Edition. I have to accept the self-signed certificate and then click the button to switch over to use local credentials, not SSO or single sign-on. I'll leave the domain name as the default, and I won't click MFA as neither SSO or MFA have been set up yet. After logging in, I'll go to the Infrastructure tab and begin creating the cluster blueprint. I'll give the blueprint a name, choose VXLAN for my virtual network overlay, and give it a few VXLAN IDs it can use. The next step is the host configuration. Since the hypervisor host only has a single interface, this is going to be a fairly simple config. Remember when I showed the Ethernet interface name? I'll enter that here and give it a physical network label, which we'll use later when creating a physical network, and then assign all the different management traffic types to this interface. In a production deployment, these would be on different interfaces. I'll skip the external storage configuration and leave the rest of the cluster defaults as is. I'll save the blueprint, go back and actually give the host config a name this time, and then move on to creating a virtualized cluster. Here, I'll give it a name, set the CPU mode to host pass-through, and then hit save. If you get this error like I did, it just means you went too fast after saving the blueprint. It normally takes about 60 seconds to restart CE's compute services after blueprint creation. So after giving it a little bit, I can successfully create the cluster. Next, I'll onboard the hypervisor host to CE. The process is straightforward. I'll follow these steps listed here and copy and paste each command to the hypervisor host. First, we'll install the pcdctl binary, or pcdctl. This is the private cloud director command line interface and is used both to authenticate a new host to the control plane, but also for running CLI commands. Then I'll set the configuration, pasting in the administrator password, and leaving proxy and MFA as none. Then I'll prep the node. You'll notice that I failed an optional prerequisite check. That is for NTP or network time protocol. In this case, it's not needed because there's already a timekeeping service that's installed. I'll continue with the installation of the host agents, which takes about 15 minutes. After the agents are installed, the host appears in Private Cloud Director as online and unauthorized. From here, I'll edit the host's roles: hypervisor, cluster membership, image library, and persistent storage if it were configured. Advanced remote support and DNS as a service are outside of this video's scope. Once I save and apply the roles, Private Cloud Director installs the binaries the host needs, which takes about 5 to 10 minutes. When it's done, the host shows its applied roles and VM scheduling status. Notice that VMHA is disabled. It requires at least 2 hosts and a control plane, and we only have 1 host in this cluster. My goal here is to deploy a virtual machine, but first I need 2 things in place: an operating system image in the image library and at least 1 network. Since I assigned the image library role to this host, and that role relies on its own security certificate, and because Community Edition ships with self-signed certificates, I'll need to accept the image library certificate before uploading anything. I actually forgot to capture that step before accepting the certificate on this host, so let's switch to another environment to walk through it. Here, I've just onboarded a host with the image library role. On the system health page, the image library shows as unhealthy, and the UI may also flag degraded services. Expanding the image service block reveals a link to trust the certificate. Following it opens the image library's API endpoint, where accepting the certificate returns some JSON confirming it's been trusted. Refreshing system health afterward confirms everything is now healthy. Switching back to my original environment, I'll upload an OS image, this time by URL rather than from a local file, though either method works. I'll paste in the Ubuntu 24.04 URL, mark the operating system type as Linux. A few optional settings follow, like making the image public to all tenants or protecting it from accidental deletion. I don't need rescue image or virtual TPM support here, so I'll leave those off and add the image. It uploads to the library with an importing status, then switches to active once the import completes. Next, I'll create a virtual network for the VM. From the Networks and Security tab, Create Network lets me choose a virtual network type. I'll name it share it with all the tenants, and add an IPv4 subnet with a name, CEDR, and gateway address. Leaving DHCP enabled means Private Cloud Director handles IP assignment, and skipping the allocation pool tells Private Cloud Director to use the entire subnet as the pool. Once saved, the network shows as active, and I can confirm it consumed one of the VXLAN IDs defined in the cluster blueprint. With a network and an image ready, I can deploy the VM. From the Virtual Machines tab, Deploy New VM opens a wizard. I'll name the VM, boot it from the image since I haven't configured external storage, select the image, then move on to pick a flavor, which is the VM sizing definition, followed by the network I just created. On the final page, I'll enable Cloud Init to set an initial password for the default Ubuntu user, then deploy. Once the VM is running, selecting it surfaces a context menu with options like power operations, network and security group changes, cloning, snapshotting, or migrating to another host if one were available in this cluster. Opening the VM console confirms the IP address is set. It's great progress, but this VM sits on a virtual network with no path out to the internet. Getting it there requires a public network and a software-defined router. Back on the networks page, I'll create a physical network instead. I'll name it, I'll keep it as a Private Cloud Director managed network, and select the label designated for external traffic in the cluster blueprint. I'll set the network type to flat and leave the remaining defaults as is. In the subnet section, I'll add a name, an IPv4 CEDR, a gateway, then disable DHCP so VMs placed directly on this network won't receive an address from PCD. I'll still define an allocation pool here for floating IPs, which can later be assigned to VMs on virtual networks. On the routers page, I'll create a router, name it, select the external network, and attach the virtual network subnet to it. With the physical network in place and a router bridging it to the virtual network, the VM now has a path out to the internet. So there you have it. We walked through VMware vCenter, then we moved over to the operating system install for Community Edition and the hypervisor host. We deployed CE, onboarded a hypervisor host, and then deployed a VM that can get out to the internet.